Hello and welcome. Today we'll be solving another question on bending stresses in a beam. And the question says a rectangular beam 200 mm deep and 300 mm wide is simply supported over a span of 8 meters. So the first thing is to draw the rectangular beam. This is the rectangular beam and the depth is 200. The base, which is the width, is nothing but what 300 mm. All right. And they said it's simply supported over a span of 8 meters. So this is a simple supported beam without this uniform distributed load. This is a simple supported beam and the length is 8 meters. So they say what uniform distributed load per meter the beam carries. That is what uniform distributed load that this beam will carry. All right. So and if the bending stresses is not to exceed 120 Newton per mm square. All right. So the first thing is to draw this rectangular beam, while the next thing you are going to draw the simple supported beam, which is going to carry an unknown uniformly distributed load, because it is that weight on the weight on the that the uniformly distributed load carried that we want to calculate, that is W. All right. So if you draw this, if you are conversant with shear force and bending moment, well, you will know that if we have a uniform distributed load on a simple supported beam, they are going to have equal reaction. So which is going to be WL over 2, WL over 2. So the given data here, we are given the depth, the base, which are in mm, and the length, which is in meter. We convert it to what? Millimeter by multiplying by 1000. And then we are given the maximum stress. So for us to solve this question, the first thing we are going to do is to solve for the sectional modulus of this rectangular section. So we know that Z is equals to BD square over 6. All right. So the next thing we are going to do is to substitute. Our B is 300 multiplied by D. D is 200. So we are going to have 200 square divided by 6. All right. So if you press this correctly, your answer is going to be 2 million mm cubed. All right. So that will be the sectional modulus. All right. So the next thing we are going to recall, we are going to be calculating the maximum bending moment of this beam. If you check our video on the practical application of flexural equation, I have told us if we have a uniform distributed load that carry a uniform distributed load throughout the span of the beam, the maximum bending moment, the maximum bending moment is going to be WL square divided by what? Divided by 8. All right. So this will be equals to W multiplied by the length of the beam is 8. 8 square all over what? 8. So 8 here will go with one of these 8 here, then we'll be left with what? W8. So which we can write as what? 8W. All right, 8W. So, but what will be the unit? The unit is going to be what? This unit here is going to be in what? Newton meter. So it's going to be Newton meter. All right. So the next thing you are going to recall, from the equation of our flexural equation. We said that our maximum bending moment is equals to maximum stress multiplied by what? Multiplied by the section modulus. All right. So we know what our maximum stress is. So and we know what our maximum maximum bending moment is, and then we know what our maximum stress is, and we know what our sectional modulus is. So our maximum stress is 8 W Newton meter. Don't forget, it's in meter. And the unit of this is in millimeter. The unit of this too is in millimeter. So it definitely means we need to multiply this by 1000 in order to convert it to what? Millimeter. So it means if we want to substitute for maximum bending moment here, we are going to multiply this by 1000. So it's going to be 8000 will be equals to maximum stress is 120. So it's going to be 8000 W equals to 120 times Z, and our Z is 2 million. All right. So for us to get what our W is, we are going to divide both sides by 8000. All right. So this will go with this, and our W now will be equals to what? So our W is going to be equals to 30,000. So we are going to have this to be 30,000 Newton meter. It's going to be 30,000 Newton meter. Or you can take it to be 30 kilo Newton meter. All right. So it's going to be per meter because it is uniform distributed load. So Newton per meter. Take note of that, please. All right. So here is going to be the solution to the above question. It's very simple and straightforward. Thank you.